Right. The objective of the webinar today is to underline the principles of the ID procedure and to link this type of process with smart building technologies. The contents would be an introduction which will give a picture about the current state on energy efficiency and nearly zero energy buildings in the European Union. The integrated design step-by-step process from the initial concept to in-use phase of a building. We will give a picture about the current policy framework in the European Union in order to promote the ID procedure as a supportive tool for nearly zero energy buildings. Also, we will refer to smart building technologies to achieve high energy performance and sustainability, and a development of a collaborative methodology in order to incorporate energy management and smart building technologies to the ID concept. And then we will conclude this webinar with some remarks and conclusions. So I will start giving the optimistic part about the energy efficiency progress that can be observed across all sectors. These are data and information from the European Commission, which state that between 1995 and 2010, the average consumption of new cars in the European Union has decreased by 27%. New dwellings built today consume on average 40% less than dwellings built 20 years ago due to the innovative technologies that are starting to get in the market. The share of refrigerators meeting the highest energy efficiency labeling classes from A and above has increased from less than 5% in 1995 to more than 90% 15 years later. And European industry improved its energy intensity by almost 19% between 2001 and 2011 compared with 9% in the United States. So about the policy and the making the EPPB pieces fit together, just to give an overview, we have standards for standardization, cost optimal reports, the aspect of nearly zero energy buildings, EPPD standardization, and EU certification schemes for residential and non-residential buildings. The timeline that has been stated for nearly zero energy buildings and related actions according to the recast EPPD from 2010 to 2021. So from 2010 it was the recast publication, and then we have over time Commission reports on evaluation of the national NZEB plans, Commission report on evaluation of NZEB plans and for milestones of intermediate targets for energy performance for new buildings by 2015, and then from now on it is stated that, and it is set as a milestone that all new public buildings are NZEB, and concerning the target of 2020 and 2021, in all types, buildings in all types should be NZEB. The concept of nearly zero energy design requires integrated design, and it requires an interdisciplinary approach. So reducing the energy demand in the design phase, demand specifications of different designers and engineers such as architects, building physics, facade engineers, and in this context, the building design phase and all initial phases of a building construction and planning is of particular importance. So integrated design is a valuable assisting approach in order to reduce the complexity of the design process, in order to ensure that the implementation is defined, in order to identify the pros and cons of alternative variants of design concepts, and to allow decision makers to decide based on transparent facts. So only if the integrated design process is applied from the very beginning of the design phase, then we can assume that a cost-effective solution can be identified in order to have a nearly zero energy building, because only at this phase changes in the general design concept are allowed to be implemented in a high cost, at a low cost. Therefore, the application of integrated design is part of the best way towards the intended ends but low costs. And here we can see a diagram. So integrated design, this shows that over time the early design phases offer the opportunity for large impact on performance to lowest cost and disruption. So therefore, we can see that the shift of workload and enhancement to the early phase will probably pay off in the life cycle of the building. And here is another relevant diagram that we can see more or less the same things. So here, from the concept design, the planning, construction, operation, and demolition of a building, we can see that at the initial phase, at the concept and the planning, the cost might be a bit higher, but this pays off at the operation and at the phase of the operation of the building, which shows that the cost is lower, goes to integrated planning, and that we have very important saving potentials through the life cycle of the building. This is, of course, compared to the traditional planning against integrated design. So the ID process, what could be a definition of integrated design? It is a holistic approach which considers the design process as well as the physical solutions, and the overall goal is to optimize buildings as whole systems throughout the life cycle regarding costs and environmental performance. So here we can see that high-performing building, we can see, of course, the interaction of all aspects that lead to a high-performance building, which is sustainability, cost-effectiveness, accessibility, productivity of the inhabitants, historic parameters, aesthetics, functional aspects, and safety and security. So these are targets that are not easily to succeed without having an integrated approach. So this requires interaction and cooperation of all design team from the early stages and throughout the whole process in order to achieve high-performance buildings. And of course, this target and these goals requires the installation of smart technologies in buildings. So this is an overview. I hope you can see what we write under each step, but I will explain to you. This is a diagram that describes the integrated design process and the ID steps from the client, from the very initial stage of client requirements to brief-writing, the concept and detailed design, construction documentation, and the post-completion and monitoring of a building. So, starting from the very initial phase concerning the project development, this includes discussion for the project ambitions and challenges, and the initial client presumptions, and then the initiation of the ID process, and preferably making some partnering contracts. Then moving on to the brief writing, we have the design basis, which includes a selection of a multidisciplinary design team, which will include an integrated design facilitator, which would be the person that motivates and organizes the team and motivates for closer cooperation and openness. Of course, here the analysis of the boundary conditions of the case study is also included, and refining the brief and specifying the project goals and targets. Then we have two steps that have to do with iterative problem solving and on-track monitoring that can be combined at this phase. The iterative problem solving has to do with facilitation and close cooperation between the architect, the engineers, and all the relevant experts through workshops. The use of both creative and analytical techniques at the design process, discussion and evaluation of the multiple concept, and finalization of an optimized design. On-track monitoring would include the use of goals as means of measuring the success of the design proposal. And a very important issue at this stage is to make a quality control plan for the environmental performance. Also, the evaluation of the design is critical, and the documentation of achievements at some critical points after each design phase, which could make an evaluation of the goals, and if necessary, these goals can be redesigned. And then after the determination of this, we have the delivery phase, which ensures that the goals are properly defined and communicated in the building contracts, if there are some. The motivation and education, which is a very, very important part of the construction workers, a very important and a very difficult and critical part too, the education of the workers and the application of appropriate quality tests, the facilitation of soft landing, which includes the delivery of a user manual for operation and maintenance of the building at the construction and documentation phase. And then we have the in-use phase, which facilitates the commissioning and checking that the technical systems are working as assumed, and monitoring the building over time regarding energy use and user satisfaction and all other critical parameters. Moving on, we will refer, concerning this integrated design process, we will refer to the current policy framework that exists in European Union in order to promote integrated design as a supportive tool for NZEB. We will see the situation in some countries, and then we will have some conclusions on this that I think that we can tell from even the first country that is Greece, and concerning the policy framework, we will see some aspects that have to do with the building codes in this country, the environmental assessment schemes that exists, the public subsidy schemes, some building programs and regional initiatives that are related to the integrated design, rules for design competitions, policies adopted by professional associations, and other policy supporting framework conditions if they exist. So, in Greece, we see that there is a regulation of energy performance buildings that has been issued in 2010, and the directive that EPBD recast that has been adopted by the Greek legislation that has to do with, of course, with the energy efficiency, but they're not clear guidelines and not clear restrictions that have to do with ID procedure. Concerning environmental assessment schemes, there is LEED, BREEAM, of course. There is the new buildings regulation that promotes and gives incentives for buildings, for high-rated buildings according to the CANAC system, but there is no direct link concerning integrated design. There are, of course, some building programs and national initiatives such as the Covenant of Mayors program that is a mainstream European movement involving local and regional authorities and voluntary committing to increasing the energy efficiency and use of renewable energy sources. More than 60 municipalities in Greece participate in this program sustainability. Concerning the rules for design competition, the last years there have been several design competitions that focus on energy and environmental performance, but still integrated design is not a prerequisite for the competitions. And of course, we have the national directive, which provides standards to energy performance, but this also does not include clear ID references. About the situation in Cyprus, the EPBD recast and the 2010 directive has been adopted by the Cyprus legislation for energy performance of buildings and the harmonization with the directive. But however, integrated design is not included in the energy and construction regulation directives. The national tool for energy performance of buildings neither does not take in consideration about integrated design. The Save Upgrade public funding scheme for energy refurbishment has to do, of course, with highly energy efficiency buildings, but is not linked to integrated design. However, at the building programs and regional initiatives, there are some local and regional authorities which voluntarily commit to the increase of the energy efficiency and the use of renewable energy sources. And the national architectural competitions, they do not include integrated design as part of the guidelines. However, there are some international architectural competitions for maybe bigger buildings that emphasize on energy and environmental performance. ID is not a prerequisite at these competitions. In Italy, we have still some regulation and technical aspects, but not a direct link to integrated design. We have, concerning environmental assessment schemes, there is a national scheme like that that doesn't include explicit ID-addressed criterion. Other, of course, environmental assessment schemes have to do with BREEAM and LEED. There are the Italian subsidiary schemes that are not directly linked to integrated design. So this is more or less the situation in Italy. And finally, we can see that in the UK, there is some indirect support to integrated design through planning system, but building regulations primarily focus on technical performance of built environment rather than the design processes. There is a strong drive for energy efficiency that may consequently influence the design approach, however. There is the BREEAM environmental scheme, non-domestic, and the Code for Sustainable Homes, but neither explicitly supports integrated design. But BREEAM is this type of the scheme is perhaps the closest existing role to the includes a role of an ID facilitator. The funding schemes have greater obligations than regulatory minimums, and includes the drive and the intention for collaborative or partnering working practices, and increasing the requirements for soft landing for both for all integrated design processes. There are education, justice, and defense that show signs for collaborative working through not directly integrated design. There are design competitions that are comparatively really rare, and they don't have a requirement of public procurement concerning integrated designs. In the UK, most institutions are supportive for collaborative working practices, although none have specific reference to this process. So this is more or less the situation in other European countries too. So what we can conclude concerning this policy framework to the EU is we can clearly see that there is no legislation obliging somebody to design with this procedure, to apply integrated design. But although integrated design is not generally a requirement, a set of policy framework conditions contribute to push ID forward. The type and the extent of these frameworks vary from country to country, and policies adopted, for example, environmental assessment schemes and in rules for design competition, supports the idea of the integrated design, and also professional associations generally recommend this collaborative type of working practices. Furthermore, educational institutes are usually supportive of collaborative and cross-disciplinary work. The integrated design is introduced in most European countries at various architectural schools, and thus it is adopted by future decision makers. Such education is a supporting policy in this sense, and could probably turn out as the most promising framework in promoting the ID process. So moving from this procedure and the important means for implementing this procedure, that is, as I said before, the integration of smart technologies. We will see now what is the situation concerning the electricity demand, and how this need for smart technologies and smart systems, smart grids and smart buildings is so important and is implemented nowadays. Electricity is the most versatile and widely used form of energy, and global demand is growing continuously. The generation of electrical energy, however, is currently the largest single source of carbon dioxide emissions, which makes a significant contribution to the climate change. And in order to mitigate the consequences of climate change, the current electrical systems needs to undergo significant adjustments. Most of today's generation capacity relies mostly on fossil fuels and contributes significantly to the increase of carbon dioxide in the world's atmosphere, with negative consequences for the climate and the society in general. So, in order to satisfy both the increasing demand for power and the need for the reduction of carbon dioxide emissions, we need an electric system that can handle these challenges in a sustainable, reliable, and cost-effective way. Smart grid is an evolved grid system that manages electricity production, demand, and distribution in a sustainable, reliable, and economic manner, built on advanced ICT infrastructure and tuned to facilitate the integration of all types of systems that are involved. The benefits of a smart grid is the on-site production, the monitoring of energy production and all functions of the energy network, the reduced operations and management costs for utilities, and consequently lower power costs, the prediction and management of energy demand, the increased integration of large-scale renewable energy systems, the maximization of energy savings and reduction of losses from renewable energy sources, the diagnosis and management of damages of the system in real time, demand response, and improved security. So here we can, excuse me, sorry. So here we can see a picture and the interconnections of smart grid and all other aspects that have to do and interfere with the system and affect the system as homes, factories, nuclear plant power, thermal power plants, hydraulic power generation, photovoltaics and renewable energy sources, ecological vehicles, and consequently cities and offices.
Then, sorry.
Yes? Dania, do you want to say something?
Excuse me, Theoni, sorry.
Okay. So here is another picture of smart grids and network of integrated microgrids that can monitor and heal itself. And we can also here see the smart appliances, the demand management, the detect of fluctuation and disturbances, and the signals for areas that can be isolated, generators and energy from small generators and solar panels that can reduce overall demand of the grid, and another basic aspect of the grid that is the storage. That energy generated that off-peak times could be stored in batteries for later use. Now we can move on and we can connect smart grids with smart buildings, and the use of internet and smart meters and smart grid building management in order to have this application of smart grids in smart buildings. Here we can see the building progress and at the same time, let's say a smart building profile that have to do with the building category, from each building category with the control flow and other aspects. So, for the intelligent or smart, let's say, building, control flow is an interactive aspect concerning comfort and efficiency information input. In smart buildings, there is systems and data integration concerning occupant and occupant interaction and efficiency. In smart buildings, we have more control and higher efficiency concerning the aspect of materials and construction. We have IP backbone used to integrate building service systems and adaptable building structure with reactive features. And concerning the interaction of operation with occupants, we have real-time integration and optimization of building systems with the building use. So, a smart building should not only or simply contain the system that all the systems that provide comfort, light, safety, etc. The building should connect the various pieces of an integrated, dynamic and function in an integrated, dynamic and a functional way. The vision is that a building fulfills its missions when it minimizes energy costs, supporting a robust electric grid and mitigating environmental impact. Smart buildings deliver useful building services that make occupants productive at the lowest cost and environmental impact over the whole building life cycle. And reaching this vision requires adding intelligence from the beginning of the design phase, as we said at the integrated design. So this should start from the design phase, from the early stages of the design phase through the end of the building's useful life. Smart buildings use information technology during operation to connect a variety of subsystems which typically operate independently so that these systems can share information to optimize the total building performance. So, enabled by technology, the smart building connects the structure itself to the function in order to fulfill connecting to the building systems, connecting to people and technology, to the global environment, connecting to the smart power grid, and consequently to an intelligent future. So, smart building provides an actionable information regarding the performance of the building systems and facilities, proactively monitors and detects errors or deficiencies in the building systems, integrates systems to an enterprise business level for real-time reporting and management utilizations of operations, energy, and occupant comfort, and incorporates the tools, technologies, and resources and practices to contribute to energy conservation and environmental sustainability. In order to see what type of technologies support this type of grids, we can have a reference to the Internet of Things. This type of advanced technology is actually the interconnection of components and systems with the Internet. It enables devices to send and receive data over a network, communicating without human-to-human or human-to-computer involvement. So this enables more efficient and productive use of assets and processes. The Internet of Things is a new paradigm that is quickly gaining ground of modern wide and wireless telecommunications, and recently, as the number of this type of devices increases in all sectors, the use for a unified control and cooperation utilization is required. Even if at many cases, or most probably, the things and the systems that are connected to this interconnection are generally heterogeneous. The Internet of Things services and the applications make use of the connections that are created via these communications and transfer data into useful information, enabling real-time knowledge discovery and decision-making. Here we can see that the dimension that is introduced in the Internet of Things, we have 3 dimensions, which is time, place, and things. Here we can see that we have any place communication, outdoor, indoor, or at the computer, or far away from the computer. Anything communication, which means between computers, between human to human, not using a computer, between human to thing or a system using a generic equipment, or between things to things or systems to systems. And anytime communication, which means day, night, on the move, whatever. A technology that is related to this IoT concept is cloud computing, which is a new tendency for efficiency managing and processing of energy sensing data for smart buildings. Cloud computing is a new method that refers to centralized storage, share data processing tasks, and online access to computer services using remote servers hosted on the internet. The major challenge in a building management system design for such building is to minimize the energy consumption without compromising with the user's comfort. A smart building on IoT and cloud-based technology can perform collaboration and efficient operation with various sensing devices in buildings and facilities. Also, applications of the IoT and cloud computing, smart buildings for the real-time building monitoring and management systems for the building energy forecasting. And this proposed system selects an optimum device feature subset from the computing resources and storage by the cloud-based building management system, BMS. So here we can see a proposed system architecture for smart buildings, which includes 4 modules. Excuse me. So it includes 4 modules as a smart building with IoT service devices, a data center, a building energy forecasting center, and a cloud-based building monitoring and management center. And through the cloud network, all these systems, we can see that they are interconnected. So here we could see, I just wanted to show you an example of interconnections of advanced systems and advanced technologies that relate to smart buildings with advanced devices. So in order to conclude, we can see that smart buildings, we could say that smart buildings are buildings that are empowered by information and communication technologies in the context of emerging advanced technologies, which might be something like the Internet of Things. The installation and the function of these technologies, in order to be cost-effective and in order to have a high energy and environmental performance, demand the incorporation of all these technologies at the building concept from the early design phases, which is the main basis, let's say, or the main objective of the integrated design. And all this has to be done through an interdisciplinary procedure that the integrated design states. So I guess that this would be all at this stage from me. Thank you for your attendance.
Thank you, Theoni. I would like now to give the floor to the Cyprus Institute, to Despina Tsegidis, to manage the discussion. Despina?
Yes, hi. Thank you very much, Theoni, for the very interesting presentation. I would like to invite everybody to express any questions they might have on this. Any questions by anybody? No. Filippo?
Can you hear us?
We can't hear you, Filippo.
Is it okay? Can you hear us?
Yes.
Yeah, hello, I'm Fabio. Filippo is here close to me. Very nice presentation. Just one thing we want to introduce in the discussion is the retrofitting of existing buildings. That we think is a real challenging issue for all that. And my team, we need some specific approach in integrated design.
Theoni?
Yes.
Did you hear, Theoni, the question?
Yes. It is about the retrofitting of existing buildings, and I didn't hear very well the other part. Excuse me.
Yeah, I was saying that as we have a lot of built environment, we should have some specific approach for integrated design on existing buildings. That they are quite different from new buildings, and so we need something that I think should be different from the standard approach of integrated design for new buildings. For example, you have already some users of that you have to involve from the beginning.
Yes. Well, integrated design has to do with the design of the building from the very first phase to the very last state of the building. So when we talk about retrofitting, these are concepts that we have to take into account. I mean, when we retrofit a building, we have to do it. This might not be the exact steps of that we should follow, but we should do it in a holistic way, taking into account all building aspects from the very early design of the building. So when we do a retrofit, we should take mainly the steps might be the same to have a good and an efficient result for the building. I don't know if you have a question on this, or if you want to discuss something more on this. You mean that the process might differentiate a bit when we are talking about the renovation of buildings, but the main steps concerning integrated design is more or less the same. Destina, I don't know what you think about it.
Yes, what Theoni is saying is very important. The integrated design approach should be throughout all the stages of design, even of refurbishment at any later stage. But it's very important in the very beginning of the design, when the determining decisions are taken about the design, to do it in an integrated manner and to do it properly, so that it will save later on the very costly approach of trying to mend things up if you omit to take the important decisions in the very beginning. But even when you do the refurbishing, one cannot just take into consideration only one parameter of the refurbishment of the building, let's say adding photovoltaics. He should take into consideration all other aspects, refurbishment of the envelope, but at the same time to see the effect that the other refurbishing parameters he includes in the refurbishment stage will be taken into consideration. Any other questions?
Destina, I have a question. Denia speaking.
Yes.
Denia.
Can we go back to this slide that we had the diagram showing the cost of the integrated design and This was very interesting.
I suppose you mean this one.
Yes, I mean this one.
Yeah.
If you see if we see this diagram, then where is the integrated design where is the integrated design cost? Is it this red line then?
No, this red line it does not show exactly. Wait a minute. Just a second.
Must be the dotted
The red line. The red line is of this diagram is the effort.
All right. Okay.
The work effort. That is
for the integrated design.
Yes, for the integrated design. The gray and the dotted line are the costs.
Okay. So we see here that during the operation, then we have the effort is very limited. While if you include what Fabio said about retrofitting, I think this diagram may change. No?
When we are talking about retrofit?
Yes.
Yes. It might change a bit, depending on the costs and on the concept of the retrofit.
Okay. Okay, that's it. Thank you. This
is
very nice.
More or less, I suppose more or less it will be the same. It will be the same, yeah.
Okay.
Well, when you retrofit, Denia, there are several parameters that are taken into account. Here we are talking about the integrated design that, as Despina said before, we are taking into account all aspects from the early stage to the demolition of the building. And this is in a step-by-step way. When we are talking about retrofit, we should take into account each building and each case as a different one, because in the retrofit we have a given state of the building, and with this given state we don't know if it's good. In some building it's good, in some building it's bad, in some building it's worse. So with the given state of each building, this it differentiates the procedures and the costs.
Okay, yes, I agree. Thank you, Theoni. It was very nice, very interesting presentation.
Okay. Thank you.
Well, are there any other questions from any participants on this? Well, thank you everybody for participating in this webinar, in the very first webinar of this series. Thank you very much, Theoni, for the interesting presentation.
Thank you all for your participation. Thank you, everybody.
And I don't know, Dania, do you have anything to say to all of us before we end this webinar?
No, it was very interesting, and I think it was a very good start.
Okay.
Yes.
Thank you very much, Dania.
Well,
thank you, thank you, everybody.
Thank you.
Bye,
Looking forward to the next one. Bye.